Welcome everyone. Today we are going to focus on problem solving using the read, draw, write strategy. Okay, really quick. What I want you to do is use the reaction tab, and I want you to give me a thumbs up if you have heard of, used before the read, draw, write strategy. Perfect. I see all the thumbs up. I see that many of you gave me a thumbs up, but I do see that some of you did not give me a thumbs up. So what we're going to do is we're going to look at the read, draw, write process. And basically it's a systematic approach that we give students so that they can apply it to problem solving and be able to internalize the thought process behind actually solving their problems using models. So with the read, draw, write process, the R represents read, the D represents draw and label, and the W actually has two parts. One part is write an equation, and the second part is write a statement. So we're going to get right to it. I'm going to share my screen because I want to see begin solving the problem. Okay, so we're going to read it together. Don't unmute yourself. Just choral read with me. In 1 year, a factory used 11,650 meters of cotton, 4,950 fewer meters of silk than cotton, and 3,500 fewer meters of wool than silk. How many meters were used in all three fabrics? Okay, so let's get started. I want you to think of two things as we go through this process. I want you to think, what do you see? And I want you to also think about what can you draw. So let's start again. In 1 year, a factory used 11,650 meters of cotton. Okay, what do you see and what can you draw? So there's two questions that I just asked you. I want you to type in the chat box, what do you see? What can you draw? Excellent. I see in the chat box that you see 11,650 meters of cotton. And some things that we noticed that we could draw is we could draw place value chart. We could draw the tape diagram. Excellent, excellent. So we're going to use the tape diagram as well as the place value chart today. So the first thing I'm going to draw is, let me draw my tape diagram. So we read it. Now we're going to draw, and this is cotton, and it represents 11,650 meters. Now don't forget the unit. So 11,650 meters. The next part, remember, same questions. What do you see? What can you draw? So we have 4,950 fewer meters of silk than cotton. In the chat box, go ahead and type that. Two questions. What do you see? What can you draw? Perfect. Same thing. I see the place value chart. I see, well, somebody said number bond. So yes, you could represent it in a number bond because there are parts to this. We know that they used the original amount was 11,650. Fewer was 4,950 fewer meters of silk than cotton. So yeah, you could do that as well. But we're going to stick with our tape diagram. So I'm going to go ahead and draw silk. And this time I'm going to do a little bit different. I'm not going to fill it in there. I'm going to use this little piece because we said fewer, so we really don't know what silk represents. So I'm going to put a question mark there because I know I'm trying to locate that. Excellent. And I still saw the place value chart. So if we're looking at this and we know that it's 4,950 fewer meters of silk than cotton, go ahead and type in the chat what kind of problem you think this is. And then as we keep going, I'll confirm if that's correct or not. Okay, it is application problem. I see also it's a comparison problem, a subtraction problem. Awesome. Okay, let's keep reading. Let's do the next one. Let me go ahead and underline what we saw in there. Let's continue reading. And 3,500 fewer meters of wool than silk. Okay, same questions. What do you see? What can you draw? in the chat. Excellent. You all are getting good at this. So we saw 3,500 fewer meters of wool than silk. Now, I want to confirm, I asked you guys a question earlier, what kind of problem this was, and you said a subtraction problem. You said that it was a comparison problem. I have one more question, and then I'll confirm. So let me go ahead and draw this. I'm going to draw my tape diagram, because this is what we said in the chat that we could draw. That represents wool. I have to be sure that I label it. This is the same thing because it said fewer. It said fewer. So I really don't know how much wool is there, but I do know that it's 3,500 fewer than silk, but I don't know what silk is either. So finally, let's read the last part of our problem. How many meters were used in all three fabrics? So now they're asking me about all three fabrics. What I'm going to do is put it together, because now they're asking me about all three of them. But do I know the answer to that? No. So I'm going to put a question mark there. So let's go ahead and get started with everything. With my model, what conclusion can I figure out from the drawing? So this is going to take us back to that question. What can I figure out? In the chat box, I want you to go ahead and type that, and then we're gonna talk about the pieces of it. Okay, what conclusion can I make from this drawing? Yes. Okay, addition, I am going to be adding something. Just remember, earlier we were talking about in the chat box what kind of problem it was. I see subtraction, yes. And we're back to comparison. Awesome. So this is a comparison problem. We are comparing silk to cotton and then wool to silk. And then we're going to see how much was used in all. So we actually have the subtraction, the comparison, and the addition all in one problem. So let's actually work it out. So we're going to start with what we started with in the beginning. In 1 year, a factory used 11,650 meters of cotton. 4,950 fewer meters of silk than cotton. So let's go ahead and figure out our silk. So with silk, we know that it was 4,950 meters fewer. And let me go ahead and be sure I put my unit. So I'm going to be using meters here. Now, what I'm going to do, because this was another model that you all mentioned that could be used. So I'm going to use it too. And that was the place value model. So I'm going to use what we call the chip model. And I'm going to represent my 11,000. Oh, I almost ran out of space. I got to squeeze it on there a little bit. Let me just erase, because I want to be sure that you can clearly see it. My chip's a little bit smaller. So I hope everybody can see my 5 chips. So we have 11,650. Now, I need to subtract 4,950 from this. So 0 ones from 0 is 0. 5 tens from 5 tens. So 1, 2, 3, 4, 5. So they're all gone. So 0. So I'm going to actually do it simultaneously because it makes it easier and builds our students' understanding. So now we have 900s from 600. So I have 600s. Can I take 900s from them? No, what I need to do is I need to unbundle 1,000. So I'm going to unbundle one of the thousands. So I have 0 thousands now. And when I unbundle it, it's going to give me 1,000. It's going to give me 10 hundreds. So I originally started with 600. So now I have 600s plus the 10 hundreds that I just put in there. So that is equivalent to 1600s. Now, can I take 900s from 1600s? Yes, so let's take that away. 1, 2, 3, 4, 5, 6, 7, 8, 9. So how many is left? I hope you guys can see that I still have one over here. I still have one over here. So that's 1, 2, 3, 4, 5, 6, 7. That is 700s left. Now, in my thousands place, I need to take away 4 thousands, but I don't have any thousands anymore. So what do I need to do now? I need to unbundle my 1 10,000. So I'm going to unbundle my 1 10,000. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Excellent. So instead of 0 thousands, I now have 10 thousands. Okay, can I take 4 thousands away from my 10 thousands? Yes. 1, 2, 3, 4. Now that leaves me 6 thousands. So my answer for my silk is 6,700. So I'm going to write it there, because now it tells me what my model is equivalent to. Now I have to figure out my next part. 3,500 fewer meters of wool than silk. Okay, so now that I know silk, it'll be easier for me to figure this out. So I'm going to go ahead and put my silk on here. But it said it's 3,500 meters. Don't forget my unit. Than silk. So since I know that this is silk, I now need to find my wool. Okay, so this time I'm going to represent 6,700. So here we go. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. I use 5 groups because students have been learning 5 groups for quite some time, since kindergarten. So let's go ahead and start here. So 0 ones from 0 ones is 0, completed simultaneously. Then I have 0 tens from 0 tens is still 0. Now I have 500s from 700. So let's take that away. 1, 2, 3, 4, 5. So that's going to leave 200s. And then I have thousands from 6,000. So let's take that away. 1, 2, 3. That's going to leave me 3,000. So my answer for wool is 3,200 for wool. So I'm going to go ahead and write that in my tape diagram. Perfect. Now, looking back at our problem, we figured out how much silk was. We figured out how much wool was. Let's finish. How many meters? This is our right part. So we've gone through our read, draw, write. How many meters were used in all 3 fabrics? So now I've got to answer this one because it said all 3 fabrics. Now remember, what conclusion can I make from my drawing? I now have all of my values for cotton, silk, and wool. Now I can figure out all 3 fabrics. So we have 11,650 plus 6,700 plus 3,200. Now I can figure it out. So 0 ones equals 0 ones. 5 tens plus the other tens is 5 tens. Our hundreds, we have 15 hundreds. And so therefore I'm going to put a new group in my thousands place. Now I have 11 thousands here. So I have to still put another new group in my 10 thousands place. And so now I have two 10,000s. So how many meters were used in all three fabrics? I can now answer that question. So that's my final question mark. Remember what I mentioned in the beginning, the read, draw, write. The read, draw, write process has reading, draw and label, write. Remember I told you there were two parts. There was write an equation, which we've done. We've written our equations, and finally we have to write our statement. So now I always tell students to use their question to be sure that they clearly write their statement. How many meters were used in all three fabrics? I can say 21,550 meters were used in all three fabrics. Oh, it's a statement. I need to put a period. Perfect. So I have actually just completed the read, draw, write process. This will be the same read, draw, write process that you would complete with your students. Notice when I completed the process, I didn't just read the entire problem. I want you to put in the chat box really quick. I'm going to give you about a minute, and I want you to put in the chat box some of the things that you saw me do throughout this process. Excellent. I see that you all say that I read the problem and then I drew something. Oh, perfect. Someone really caught on to what I kept asking. There were two things that I continuously asked throughout the process. What do you see? Can you draw something? What do you see? Can you draw something? Okay, perfect. Several of you said that I used multiple models. I did use multiple models to help build the students' understanding. It actually aided in solidifying their equation. They could actually see it on the chip model. The bundling and the unbundling, well, the unbundling rather. I didn't do one for my final. Awesome. Okay, so perfect. You guys actually saw everything that I was trying to depict in my explanation of the problem. It's actually chunking the problem, and it's creating that internalization that I mentioned early on that we want our students to do. With them being able to do this, it'll solidify the thought process that they need to efficiently and accurately solve word problems.